naming and formula writing. In this video, I'm going to be going over how to name ionic and molecular compounds based on their formulas and how to write balanced equations. Rules for ionic compounds. Ionic compounds are bonds between metals and nonmetals, and this occurs when metal atoms lose electrons and become cations, and nonmetal atoms gain those electrons, resulting in an anion. This means that the amount of electrons lost by the metal must be equal to the amount of electrons gained by the nonmetal. And to know which charges these ions will have, the common oxidation numbers are listed on the periodic table to help. Writing ionic compounds. For example, let's take the formation of NaCl or sodium chloride. To form sodium chloride, you need sodium and chlorine. So you'll take the atomic sodium, which is Na, and chlorine, which is Cl2, since it's diatomic. Then you can look at the charge. Since sodium has an oxidation number of 1, it will become a Na plus ion. And for it to bond with a chlorine ion, the chlorine ion must have a -1 charge. And out of the multiple oxidation numbers for chlorine, -1 is one of them. Therefore, sodium becomes +1 and chlorine becomes -1, which add up to 0, creating a neutral compound of NaCl. However, you still need to balance the equation. Since you have 2 chlorine molecules, you will have to have 2 sodium chloride molecules, and therefore you'll also need to have 2 sodium molecules on the left. And to balance this, you can simply add a 2 in front of the sodium and a 2 in front of the sodium chloride. Now let's try a more challenging example. Let's take the formation of iron oxide, specifically iron 3 oxide. Iron 3 oxide consists of iron losing 3 electrons and having a +3 charge. And it's important to note that when you name ionic compounds that contain a transition metal, like iron, meaning it has multiple oxidation numbers, you'll need to specify which charge it has using a Roman numeral. So for the formation of iron 3 oxide, since we know that the iron loses 3 electrons and has a +3 charge, while the oxygen typically gains 2 electrons and has a -2 charge, we need to know the least amount of electrons that iron can lose and oxygen can gain that adds up to 0. Knowing that iron is +3 and oxygen is -2, you can multiply iron by 2 and oxygen by 3 so that 6 electrons are lost and 6 electrons are gained. This will give you Fe2O3 as the formula. Then you have to balance the equation by seeing that there are 2 oxygen atoms on the left and 3 being used on the right. So you would do the same thing as you did with the electrons, but this is to balance the element on each side. And you would put a 3 in front of the O2 on the left, and you would put a 2 in front of the compound on the right. Now that you have the 2 molecules of iron 3 oxide, you will need to put a 4 in front of the iron because on the product side there are 2 molecules of product, each with 2 atoms of iron, therefore needing 4 iron atoms on the left. I know this one was a little more tricky, but it's still the same steps that are listed on the side. Now moving on to naming ionic compounds. Ionic compounds kind of have a first and last name situation. They have 2 parts, one which is the metal name followed by the nonmetal ion name. The metal is usually just listed as the same as the element, and the nonmetal usually has the suffix "ide" unless it's a polyatomic ion. And a reminder of the polyatomic ions, or the most common ones, are listed at the side so that you don't use the suffix "ide" with these. So some examples include sodium chloride, NaCl, calcium oxide, CaO, and lastly, an example with a polyatomic ion is silver nitrate, AgNO3. Now let's move on to the rules of molecular compounds. Molecular compounds are bonds between nonmetals and nonmetals. Bonds form because the nonmetals share electrons and create covalent bonds. There are two types of molecular compounds. There's normal molecular compounds and acids. Acids are compounds that begin with hydrogen, while the other molecular compounds don't. So, although it doesn't seem like it, water, or H2O, is technically an acid, except it's very weak. To write molecular compounds that are not acids, you need to know the formula of the compound based on the name. This will be explained later on, but once you have the product on the right, you'll have the elements on the left, and then you simply balance the reaction like before. So, for example, carbon dioxide is basically one carbon molecule and two oxygen molecules. And you know this because there's a prefix di in front of the oxygen, which stands for 2, and then you can balance the left side. But since we already have two oxygen molecules on both sides and one carbon molecule on both sides, this reaction is already balanced. Now let's try writing the formula of an acid. Let's take the formation of hydrochloric acid, or HCl. HCl is made up of hydrogen and chlorine, which can be put on the left, and the formula HCl, which we can put on the right. Now, to balance both sides, there are double the hydrogen and chlorine molecules on the left, since they are both diatomic. Then on the right, you will need to simply add a 2 in front of the HCl to balance the equation. These are two simple examples of writing molecular compounds. However, to write the formation of molecular compounds, you need to know how to name molecular compounds, which is the hardest part. So starting off with regular molecular compounds, they are named by their prefixes. Their prefixes show how many of that element belong in that compound, and they start at mono, meaning 1, and they go all the way up to deca, meaning 10, and they continue on, but those are the primary ones you will need to know. So, for example, carbon dioxide, as we mentioned earlier, is 1 carbon and 2 oxygen molecules. And then you can take, for example, dinitrogen pentoxide, which is N2O5, is named by the prefix di, meaning 2, and the prefix pent, meaning 5. However, there are a few exceptions, such as hydrogen peroxide and methane, which is CH, but it's not named by its prefix. But mostly, the majority are named using prefixes. Now moving on to naming acids. Since there are different types of acids, strong versus weak acids, they're also named differently. Strong acids are acids with polyatomic ions, whereas weak acids are anything else. So weak acids are named with the prefix hydro, followed by the element and followed by the suffix ic, and then you can add the word acid. So examples include hydrofluoric acid, hydrobromic acid, and hydroiodic acid. On the other hand, strong acid forgoes that prefix hydro, but the rest remains the same. So, for example, nitric acid, sulfuric acid, and carbonic acid are examples of strong acids. So I know this was a lot of info in one video, but I hope this helps you out. Naming and formula writing is one of the most essential things for chemistry, and knowing the basics will really help out in the long run. I hope this helped, and once again, feel free to like and subscribe for more. Thank you.